projects, right? So precisely that is the situation of energy efficiency also. Not even a single technology, you can call it as a good or you can call it as bad, right? But end of the day, what happens is all these technologies are finally retrofitted into your plant operations, right? So that is why the benefits, precisely that is the situation of energy efficiency also, which is coming up in your plant, is a cumulative effort of each one of those things, right? So let me take you through my presentation. Is my screen visible? Great. So what we are sharing with everyone here is how we achieved over 20% savings and delivered month on month, right? And we have distributed this into 8 session series, right? So today's session is the second session in that, right? So it's on finalizing of projects, right? So the total 8 session series, it is like this. The first one was defining baseline and ideation. Those who have not attended this can go to our YouTube channel, and the whole and full recording of it is available on that. You can see that it was conducted on 6th October. That was Wednesday. Otherwise, all the sessions are going to happen on every Tuesday, right? Now onwards, we have taken care that a typical holiday should not come in that, because we are into Dashara and Diwali kind of situation. So that's not the case, right? So the session which we are going to take today is finalizing projects, right? Because in ideation, you get plenty of ideas. You get enormous project thoughts, right? Enormous number of project proposals as well, right? So how do you finalize, right? Because finally you are aiming at a certain percentage of savings. So that is the objective. Objective is not to implement this project or that project. Objective is to reduce your specific energy consumption. Objective is to reduce your daily overall energy consumption. Objective is to see that the savings can be realized in your electricity bill, in your fuel bill, right? Unless and until finance guys are saying that, yes, the bill is really reduced, the purpose of the project or the purpose of the whole initiative is undone, right? So then we will see financing. What are the various methods of financing an energy efficiency project, right? The procurement of energy efficiency project is also quite different than normal project implementation, right? Or normal production kind of procurement, right? Or normal services procurement, right? It's quite different. So we will discuss one complete session on procurement. Then implementation. What are all those issues which are there in the implementation, and how do we take care of it, right? And once the project is implemented, then how do we carry out daily monitoring, right? I mean, are we getting the intended measures, right? What are the corrective actions which are needed? And finally, daily savings must result into the monthly energy savings. And what is the measurement and verification protocol for your savings? How you are going to monitor that? That also we are going to share, right? Then finally, everything is going on, everything going all right, right? But the operation and maintenance of energy saving project is also a very, very unique thing, right? Because here, if it is not done properly, then your energy saving potential, which was coming up very nicely, that gets reduced, right? So N&M strategy for energy saving project is also very unique. And then in the 8th, we will take summary of all the learning from all the sessions. So on 23rd of November, we hope to complete this series. Friends, let's proceed further, right? So these 2 slides are basically I am covering the previous session, learning from the previous session, right? So the previous session was baselining. Baselining means what is the energy level from which you are trying to compare, because energy saving is finally difference in 2 numbers, right? So difference in 2 numbers means whatever project you will do after that, whatever would be the energy consumption, that level you would come to know. But what is the number with which you are going to refer, right? So that is called as your baseline, right? And how do you do baseline fixation is called as baselining, right? And how do you do it is actually going to decide success of your project, right? Because there is an effect of production on that, right? If it is a manufacturing unit, right? If it is a building, then is it a winter season? Is it a summer season, right? So that is also going to affect it, right? So how to measure, right? In a renewable energy project, what happens is how much is the kWh generation, right? That is one single parameter on which you can measure the success of a solar photovoltaic project. But that's not the case with energy efficiency, right? Energy efficiency project has got several challenges. So every project has a unique way of quantifying savings, right? And it should be transparent. It should be acceptable by everyone, right? So that's what the second point is, that the stakeholders agreement is absolutely necessary, right? And our suggestion is that despite so much of models or methods are there, but keep it simple, right? Anything which is kept simple is actually understood and agreeable by everyone, right? There has to be complete transparency from client side, ESCO, and the OEM, right? These three entities are and their coordination is absolutely necessary for doing any energy efficiency project. Doesn't matter you come from a client side or a ESCO side or a OEM side, right? Unless and until a tripartite comfort level is not there, things become very difficult to actually do it, right? But by telling all this, I'm not trying to increase the worry factor. What I'm trying to do is that once you take care of all these factors, your project runs really, really smooth, right? So now there was one very important learning out of it, that the moment you have the baseline, right, then you know that how you can compare it with the baseline of other processes, other facilities, or other technologies, right? And that gives you a reflex diagnosis of the existing system, right? I mean, whether there is higher potential or whether there is less potential, you can simply tell this by knowing the current energy consumption levels itself. It is possible to do that, right? And then you get the plant data, and then you reach out to the diagnosis, and then you reach out to the right ideation, means what are all those initiatives which are possible, right? And friends, remember, energy saving is a very, very long-term phenomena. Whatever project which you have done has to deliver you outcome on month, year on year. Let's proceed. Then ideation means what? That is the baseline which we have done in the earlier slide. So baseline is the specific energy consumption or daily energy consumption levels, right, in any facility, right? And then comes that if this is the specific energy consumption, if this is the energy cost, right, then what should I be doing, right, to reduce my energy cost? So that is called as ideation, right? In energy audit, normally what is the outcome is the ideation phase, right? So our suggestion here is very strong, that you have to always begin with your baseline, because that is your own data, that's where from you start, right? And not with a preconceived mind, right? Because number of energy efficient technologies are so many, and many of us are aware of like which energy conservation technology is applicable in this case. And then we see to it that let's implement this technology, and then let's see that whether the payback period is good or not. And if the payback period is good, let's recommend it to management, and let's try to get the project sanctioned, and then let's try to do the project, right? I would say that's a very short-sighted kind of approach, right? Because every rupee, right, whether you are investing in a energy efficient motor or on a LED or on a heat pump, right, the outcome of every rupee invested is actually rupee saved, right? And rupee invested versus rupee saved is not a primary function of any specific technology, right? Different technologies are actually good different options, right? But for every project, for every site, for every process, right, a separate set of ideation must be done based on the diagnosis, and then the project should be recommended. So that is why we always do fresh work, right? In any case, we do fresh work. Your all the experience actually improves your competence, but not like a control C, control V, or like not like a copying, right? Because this has given good savings here. That is the reason why it will give good savings. Elsewhere, it doesn't work out like that, right? You do the ideation specific to that particular case, you carry out all the diagnosis, and then you implement it. That's how it works, right? Verification of baseline is very important, right? Then with every ideation, right, and you will implement the project, right? But that also means that you have lost one opportunity, right? Suppose if you are settling up with the second or third best kind of a project, right, your baseline will change, and then your best project, you will not be having feasibility, right? Like for example, there is a motor, right, and you are trying to change it with i3 motor, and then there is a feasibility. You find that 1.5 years is there, management is okay with it, and let's do that, right? But then what happens is, when you try to evaluate the feasibility from IE3 to IE5, right, then your payback period becomes 5 years, right? Whereas in the beginning itself, right, if you would have done the project with IE5, then your payback would have been slightly higher, but your savings would have been far, far better, right? So that is the reason selection of the projects becomes very, very important, right? So that was the learning, right, from the last two sessions. So friends, let's proceed further with today's topic, that is finalization of projects, right? I would like to begin this session with a saying that there are plenty of medicines in the medical shop, right? But the doctor prescribes a few based on the diagnosis, and that's what it works. So that exactly happens with energy efficient technologies. There are plenty, right? And for reducing 5% energy cost, 10% energy cost, 20% energy cost, right? There is a different set of energy saving projects, or there is a different set of energy saving opportunities, right? So that target has to be fixed first, and then coming to the projects. It's very much possible. Up to 20%, it is possible. That's what we have seen again and again. So what we are going to discuss today is why finalization of projects, right? I mean, ideation can be plenty, right? But finally, from those ideation, you are going to choose certain number of projects, right? Because you want to reduce your energy cost by 10%, 15%, or 20%, right? So we will discuss in detail why it is so critical, right? And friends, take my words that it is not about this or that technology, right? It is completely based on the diagnosis, right? We have seen quite often that at home with one particular infection, everybody gets infected. But when we go to our doctor gives quite different medicines to us, right? So that's what happens with energy efficiency also, right? Then what happens is, for example, there is a chiller, right? Or there is the injection molding machine, right? Or for example, there is a oven, right? Or furnace for any heat treatment operation. You would find that there are plenty of projects, at least 2-3 projects are possible in each of the case, right? So when you calculate savings, right, you will calculate savings from the baseline, right? And you'll calculate the savings from the baseline, and then what happens is once the first project is implemented, right, then the savings will start coming up, right? And your actual baseline is changed now, right? It is actually reduced, right? So summation of all those 2-3 initiatives, right, is not going to be your total savings, right? So that is what is called as multiplier effect. We will see it on a full slide, right? Then, so when these are the challenges, right, finally we will have to come up with a cumulative savings, right? There are going to be 5-6 different kind of projects which are needed to arrive at 15 to 20% of savings. Then how do we do summation of the savings, right? Because finally it is going to be again two numbers only, the INR invested versus INR saved, right? So that is why it is more of an art than science, right? Ideation is perfectly a science and engineering, right? But when you do the selection of the project from those ideated projects, right, it is definitely an art, right? Then again, the point is begin with the end in mind, right? It is actually what Stephen Coveys has said in his habits of highly effective people, right? So that applies here also very well, right? Because it's not we are not going to implement this or that technology or this or that project. What we are trying to do here is that this is the present specific energy consumption, this is the present energy cost, this is the present overall energy level, right? And then by doing all these initiatives, how much we are going to actually save, how much we are actually going to reduce. That's what the whole purpose is. So that thought should always be there in the mind, right? And that is why measurement and verification, that is popularly called as M&V, right? Association of Energy Engineers gives qualifications like CMVP, right? For learning how to do M&V, right? We are all aware of Bureau of Energy Efficiency, energy audit exams, right? But energy saving is much beyond that, because how do you calculate saving? So there is a whole lot of qualification meant for that, right? Then what is our process of finalizing project, right? We are sharing that, right? So what we do is we work first through data, then observation, then analysis, then diagnosis, then technological options, then various iterations for cumulative impact, then optimization, and then finalization. So friends, we will see this process in detail. Then we will see, right, doesn't matter what not technological complications are, what not level of processes or steps we may have, but end of the day, it is ROI, right? I mean, what is the investment versus what is the saving, right? So that's the small definition of energy efficiency, right? And its success is also on the basis of these two numbers only. So we will discuss that, right? we have a full case study. We will discuss that, and then we will see the summary. So I'm proceeding. Friends, whatever your questions are or your particular issues that you are facing, please keep writing on the questions, right? So friends, let's see why the selection of the project is so critical, right? So as we discussed earlier, that the number of projects are plenty. So whenever that there is a choice, right, then there is a job, right? That how we do the choosing process, right, out of so many projects, that becomes very, very critical, right? Because we have to optimize finally that my amount of money which we are investing should give us the best outcome, right? So whatever set of projects, for example, the management clears it out that you invest 50 lakh, right? But for investing 50 lakh, we expect a saving of at least 30 lakh per annum, right? So these are the two numbers which are coming, right? Then whatsoever set of projects which you are choosing, right, should deliver these two numbers, then and only then there is a purpose for it, right? However, unfortunately, we have seen energy efficiency projects and decision making coming out completely the other way, right? From the engineering, the project is conceptualized, then project is prepared, or then it is submitted to the management, and then management takes a call on that, right? Whereas it should be completely reversed, right? Because that's the way investment decisions are done, right? If we want a particular set of return, right? If we want no risk, we go for FDR, right? If you want little bit risk, we go for mutual fund, right? If we want slightly our comfort level is there, then we invest into shares, right? So our investment options are changing, right? You're getting that point, right? And that's what is there with the energy efficiency also, right? However, here, if the project is implemented properly, then the risk is not like that, right? The results are certain, right? And then as we have discussed, like for example, in furnace, right? If it is a oil-fired furnace, right, or a gas-fired furnace, right, then you will do a project of insulation improvement. You will do a project of what is the level of loading inside the furnace, right? You will do a project of how is the quality of burner, right? Then you will do a project of how is the oxygen percentage, right? So I'm just giving one example, right? So there are so many options, right? Now, how do you find out each one of these options are absolutely correct, technically correct options, right? But when you are going to actually implement it, you have to choose, right? So that you get that those two numbers finally right, right? The investment should not go more than 50 lakhs and the saving should go more than 30 lakhs. That's it, right? So that is why this process is so critical, right? And then once the project is done, operation and maintenance, right? And the life of retrofits, whatever we have done, all those things become important, right? Then we have also seen that some of the projects we have implemented at certain location and some of the projects we have not implemented at certain locations, right? Because reaching out to those locations by different technology suppliers, by different OEMs was difficult, right? So that is the reason why we dropped that, right? We choose the different projects, right? And different projects have given the final savings, whatever the saving was targeted. But these things are also important, right? Is the client team going to operate all the project, right? Are they comfortable doing so, right? Or we have to provide our team. So we have seen both types of clients, right? And there's nothing like this is right or that is right. So we have to be very specific, right? And that is the reason because once you have selected a project, right, and you are in an implementation process, then you have taken a decision, right? And in this energy efficiency projects, the decisions cannot be reversed, right? You can take your time to choose a project or set of projects, right? But once you have taken a decision, right? And friends, the fact is renewable energy works in hand to hand with energy efficiency. We have seen that after even the complete roof area is covered with solar photovoltaic, right? There are many companies, many organizations today trying to reach out to net zero, right? But their energy consumption is still higher, right? And there is no space left out, right? And then if your contract demand or sanction load is less than 1 megawatt, right? So open access doesn't apply to you, right? So in that situation, the option is only energy efficiency, right? Then finally, the thing which matters quite a lot is operating hours, right? And operating hours, particularly during Corona time, are changing quite a lot, right? So you have to consider all these kinds of variations, possible variations, right? How do you do that, right? And what are the energy tariffs? there are states like Goa where the energy tariff is very low, and there are states like Maharashtra where the energy tariff is very high, right? Believe me, our set of projects are quite different for both of the locations, right? So this is the whole gambit of different aspects which are making our selection of projects very critical and very important. Let's move further. Excuse me. Then another issue is when we are doing and implementing so many projects, right? Then finally we have to come up to that 30 lakh number, right? That 30 lakh per annum saving is what is expected out of a 50 lakh. I'm taking just two numbers, right? But end of the day, after implementation of the project, I must not exceed 50 lakh, and with 1 year of operation of energy saving project, I must exceed 30 lakh, right? This is the very straightforward purpose of any energy saving project, right? And in cumulative savings methods also, it's an art, right? Let's see the example, right? That I'm going to share here two examples, right? Impact of baseline reduction due to multiple projects, right? Like, for example, we discussed that furnace, right? There were four methods of energy saving in that. The moment you do one project, the baseline itself will reduce, right? So while your percentage saving by doing that particular measure may still remain same, but the percentage is going to get calculated from the number that is the baseline number that is reduced, right? Then you do the third project, it is again reduced, then again reduced. So you will surprise that my all the calculations are correct, but my cumulative savings is not a arithmetic sum of all of them, right? So this we have seen quite often happening, right? So you have to put your all the experience of actual implementation of the saving project and not only auditing, right? And that's the way it helps. Then let's see the other way around. Savings are more. Quite often we have seen that the savings are more. Let me discuss one of the example, right? For example, you have done an air conditioning project, right? On the chiller, you have done several things. On AHU, you have done several things. On pipeline and flow management, you have done something. Then the temperature setting of the chilled water, right? With respect to different loading, you are doing something, right? And then you have also done the LED project, right? But you are finding that the savings are more, right? So here the reasons like the savings due to heat load reduction, because you have moved away from LED lighting, from normal lighting, right? Wherein you see a lot of heat loss, right? Because your 50 watt lamp is getting replaced by 6 or 8 watt LED, right? So that much of heat load is actually reduced, right, on the chiller side, and that is the reason cumulative savings are more, right? So that's why we move more from science to art, right? And that is the reason, I mean, initially at the ideation stage, we strongly recommend go into details of the calculations, right? But when you come to selection of the projects, when you come to finalization of projects, right, then you have to put in your experience that how it is going to behave cumulatively, right? Let's see example. So this the green line of energy consumption, this is outcome of our own project implemented, right? This is on a whole facility, right? And we have done several projects here, right? And so the baseline energy cost, right? Because finally the customer or the end user finally wants the result in terms of cost, right? So you have to put the same tariff, right, in the baseline and in the post-project scenario, right? That's how you can equate the situation, right? Because on the tariff side, right, nobody has a control, right? So if the project would not have been implemented, then how much would have been the energy cost? That becomes your baseline, right? So now you see month on month the savings are achieved, right? But month on month the savings are quite different, right? It's not the outcome of the exact calculations, right? So energy saving is a number, right? But it behaves like this, right? And then what happens is your commitment that on an annual basis you will exceed your savings more than this. So that is how it works out, right? So much of detailing, so much of working is absolutely necessary, right, when we are working at a whole facility situation wherein the investments are getting more than crores, right? So friends, let's move further, right? So here are the two slides, right? Here are the two pictures, right? And I want to emphasize on the Stephen Cove's first habit. It says very clearly, begin with the end in mind, right? Energy saving is a project for arriving at a particular energy cost, right? It's not about the technology, right? Because for example, when I go to doctor, right, doctor will do diagnosis, right? I believe that this doctor is good. That is the reason I'm going to that doctor, right? But how doctor has treated me, right? How doctor has diagnosed that I'm suffering for malaria, that is doctor's competence, right? Okay, and then he treats me with different medicines, right? But end of the day, I definitely expect that I should be getting cured, and I should be getting cured faster, right? So we have to begin with the end in mind, that what is the saving percentage we are working for, right? And then if the 5%, again I repeat, if the 5% is the target, it is one way. If 10% is the target, it is another way. If 20% is the target, then it is another way. So there are at least 3 different ways which we have seen with every customer, right? So when we are beginning to implement the project, there are always multiple choices. So which one you will do, which set of projects you will implement, right? Or even if you're trying to do simulation or calculations, you will come up with so many graphs, right? And when you plot them, right, believe me, friends, even after so many years and years of experience, right, we do reach to these kind of graphs, and believe me, we don't infer anything out of it, right? So this is the precise place where your skill sets move from engineering or science towards art, right? Let's move further, right? So friends, how will you finally be demonstrating savings, right? This is very important, right? So worldwide IP MVP protocols is basically ABCD. There are 4 methods of saving calculations, and one of these 4 methods is what we have to define in the beginning of the project itself, right? Because that is the method you are going to choose it to demonstrate the savings, right? So option A, right? Let me explain to you in detail that this is retrofit isolation. Retrofit isolation in the sense that you are doing a lighting project. So before kilowatt, after kilowatt, right? I mean wattage multiplied by number of lamps, and then you'll be doing it on so many different types of lighting. But then finally the operating hours, you have to fix it, and that's the only way to do it, right? Then energy efficient motors, right? Because there is no way you are going to put energy meters on individual lights, right? Or even on a section of light, because there would be several other uh, uh, your single phase loads on that, right? Same way happens with energy efficient motors, right? Or you're trying to do with a hydraulic to servo motor, right? So what you are claiming is that initial kilowatt, right, is this much, right? If it is a fixed one, right? And then afterward kilowatt is this much. So that's how energy efficient motor projects are done. Or if it is a cyclic load, right? Like for example, hydraulic to servo motors, when you are carrying it out on a induction molding machine, right? Then what happens is you will take the observation for, let's say, 10 cycle or 100 cycle, depending on your cycling time, right? And then you will come up with an average per cycle, how much is the energy consumption, right? That's how you will demonstrate, right? Because by doing one motor change, you cannot demonstrate the energy saving on the electricity bill, right? However, we are trying to implement a project at a whole section, right? You're doing several initiative, and you're not primarily interested in finding out that what is the saving with that particular project, right? You're interested in the overall things, right? So what is the overall kWh consumption? So we are moving from kW to kWh, right, in option B, right? And then for that section, not the whole facility, right? And there you are comparing it with the before project scenario, and then you are demonstrating the savings, like for example, HVAC, your air conditioning area, right? Or hot water area, right? In case of a 5-star hotel, or in case of a hospital, right? This works out very well, right? However, the examples which I discussed, they were on the whole facility, right? Because we did so many projects, right, on the whole facilities. The whole facility, that there was no COVID impact, right? The facility was running very stable, right? If you compare their 3 years of energy consumption, right? So the variation in any of the month, right, total energy consumption was not changing more than 5%, right? So that is the kind of stability that is needed to do a project on a whole facility kind of an option, right? And that is calibrated simulation. This calibrated simulation is if you are trying to do a greenfield project, right? So if you are using a particular technology or a particular kind of machine type, right, and then you want to find out that if you do energy efficient investment further, right, like for example, if you do a project with IE2 motors or IE1 motor, right, I1 not available, so IE2 motor, or if you do the whole project with IE5 motor, then how much will be the savings? So there is no previous case available, right, to find out the baseline, right? So you do the calibrated simulation situation, right? So these are the 4 methods, right, which you have to very cautiously understand and fix it for a particular project. And whatever method for energy saving you have fixed for one particular project, that is the method is followed every time, right? You can't change the method of saving calculation now and then, right? Because that is how the project is selected, that is how everything is done, right? And this M&B method is accepted by all the stakeholders, right? So that is the importance of measurement and verification. And obviously your project finalization, right? This our session is on project finalization. So what is your project, right? If your project is just changing lighting, right, then you have to adopt option A, right? And accordingly. So friends, let's move further, right? So what is our process, right? And we have done it very systematically, because what happens is when we do work in a scaled up scenario, let's say working on a 15 projects simultaneously, right? Then how do we do it, right? It cannot be based on one person's ability, right? The processes has to be very, very clearly defined and placed, right? So what we do is that we take data, right? We take data of any facility, whether production or whether building, we take that data, right? So it is specific, it is basically total energy consumption, right? In form of electricity or in form of solar PV, if that is there, or there is a wind energy which is taken up, right? Or any other form of third party purchase, right? And then what is the fuel consumption? All that data is taken, monthly data is taken for detail, right? For almost 1 year, that is past 12 months, right? And then we also take a detailed list of connected load, right? And then we carry out a basically bench study, that is what we call it as, because till now we have not been to the site, right? And then we do that analysis, right? And whatever the observations which are coming out from that, right, we use them, right? Sometimes we do go to the site and we include those observations also, right? Now you have data, you have observation, right? And these are in discrete forms, right? Here this is what data says, here this is what observation says, so you have to analyze that. So that's our third step, right? And analysis is a generic conclusion. Still we will say that analysis is a generic conclusion, right? Because this analysis is actually leading not to an energy saving project directly, but to the diagnosis. I mean, why is that the energy consumption is so much? That is a much bigger question to be asked as well as to be answered, right? If your diagnosis is correct, if that means that why is that your specific energy consumption level is this much, right? Why is that you are consuming this much of energy, right? That is what is called as diagnosis, right? The moment your diagnosis is right, the technological options are plenty. And I again and again I will say that these are as many as number of medicines in the shop, right? But doctors gives you those few medicines based on the diagnosis, and that is the reason you get it right. It's not that because of this medicine or that medicine you get it right. Okay. Now, all those technological options you have to iterate, right? You have to make various combinations, that if I do this, then how will be the outcome? If I do that, then how much will be the option, right? And so that is the qualitative iterations, right? And then the cumulative impact is basically how much will be the savings, right? That you have to see, right? And with this, you get much better clarity on the numbers which you are going to come, right? And then we do the optimization finally, right? Before finalization, right? It is also very important, right? We can't skip that, right? So this is a long drawn process, which is based on experience, but it doesn't mean that it takes that much of time. There are systems, there are softwares, right, which we have developed, right, and also using outside softwares, right, to arrive at all this at a much faster pace. So friends, let's move further. Now, these two pictures are self-explanatory, actually. If you see, energy efficiency ROI is actually a game of two numbers, right? We have been discussing right from the beginning of the session. That is your investment and the savings. Only these two things, right? And what is the reality, right? We believe, right? Like for example, as an energy auditor, or for example, as an ESCO, right? We make a proposal, right? But what customer is thinking, right? Customer would still be evaluating whether I will get this return or I will not get this return. I will get this return or I will not get this return, right? Whereas what you are intending is saying that your savings will get cumulative, and month on month, actually your overall savings will increase, right? So the whole process, right, this whole 8 sessions, right, are actually taking the customer from the left side pick to the right side pick, right? Taking the whole fraternity from the left side pick to the right side pick. That's what is my intention. That's what is our intention to take these 8 sessions. Friends, let's move further. Now we get into the case study, right? So this is Taj Vivanta, right, which is in Delhi, right? So here the total investment of so many different energy projects, right, was 2.37 crores, right, and savings per year was around 2.03 crores. So payback period was little higher than a year, right? Then the GHG emissions and actually the ROI, right? So this is not the recommendation, right? Energy audit recommendation. This is something which was actually achieved, right? And actually, this is the project wherein we had to undergo a second set of project implementation, right? It happens that despite doing all your best effort, right, you may still miss on, right? Like for example, I'll give you example, right? For example, cooling tower is not performing, right? So that is the reason your chiller is not performing. Now you take a decision that for improving the cooling tower performance, you are going to use actually the fills replacement, or you are going to improve the airflow rate, right? So you may take a retrofit project, right? So initially we did the retrofit project, right? But then we realized that there is a still scope for a, right? So we implemented a CTI approved cooling tower, right? The CTI approved cooling towers are a bit more costlier, right? But if they are implemented there, because this cooling tower is going to decide how much is going to be your chiller consumption, how much is going to be your compressor consumption, right? The equipment which is most neglected otherwise, right? So what I'm trying to say again and again is that finalization of the project is something very, very important, right? So then we implemented variable frequency drive on the achieves, right? LED lighting, of course, right? The laundry was completely revamped. The boiler was completely stopped, right? And auto tube cleaning system, right? Because at the location, the water availability was less, right? So recycled water, it was a decision taken, right, to use recycled water, right, into the system. We said yes, energy efficiency should still happen, right? So we went ahead with the auto tube cleaning system, because when you are trying to implement project, during the implementation also several issues may come up. Maximum and many practices may get changed, right? So that doesn't mean that your energy saving project stops giving you savings, right? And then, of course, the choice was for heat pump, right? We've seen that many locations, even if water cooled chiller is there, even in that situation, the air source heat pumps are used and additional area is cooled, right? But whereas if you actually go ahead and do a little bit more of engineering, you can succeed with installing water source heat pump, right? And whatever additional cold which you are preparing, right? That cold can go for your chiller based savings. So these are the actual savings which are achieved out of actual project implementation. Then this is how the importance of M&V is. This is how we calculated actual savings, right? Then, so there were three different methods, right, for calculation of the savings, because there were three different projects, right? Three different set of projects. So accordingly, the saving was calculated, right? And you have to finally deliver and finally ensure that that 50 lakh investment is definitely resulting into 30 lakh plus of savings. So these are the actual projects which we have implemented, and a combination of all of that, right, is what has delivered savings to different sites. So friends, the summary is like this, right? Project finalization must be on the basis of overall diagnosis and not on the basis of this technology is good or that technology is good, right? And we have to ensure that within the budget allotted, right, we have to deliver the best of the combination for the energy efficiency project, right? Whatever project you might have selected, right, but is that the best project to deliver the best of the ROI? That the question is still remaining, and that has to be answered, right? And energy efficiency is finally evaluated on the basis of rupees invested versus rupees saved, right? And finally, rupee invested versus GHG emission saved, right? So there are only these two ways, right, to evaluate performance of any energy efficiency project, right? So again, I repeat that if you choose the second best or third best, right, then your feasibility for the best is gone, right? So that's why we have to do all this very, very carefully. So friends, let me showcase you certain feasibilities, certain actual projects which have been implemented. So what is actually possible is to actually come up with a EMI for customers, right? Wherein the savings are much higher than the EMI, and customers can get net positive savings. This is very much possible. It can be done, right? It has been done, right? This is with another technology, which is evaporative condenser, right? But the end result is definitely the same. That is the monthly lease rental or EMI on the customer, right, is coming out to be lesser than actual savings. So customers with energy efficiency project, the concept of paybacks are much older, right? So when the project is implemented at that stage itself, customers can get savings. So this is the third case. And this is a summary. On the left-hand side, you can see the buildings where we have done energy efficiency project. On the right-hand side, wherein we have done the projects in industries. And friends, here is a list of various technologies. And this is not the full list, right? This is endless, right? But what we have to do is that we have to always ensure that we do a very rightful selection of the technologies for implementing the projects. That's the key. And to summarize everything, right, our overall process finally turns out to be in 4 steps. So first we do the energy cost analysis, right? Then we do the opportunity evaluation. Then we do the system optimization. And then we finally transfer the savings. Thank you. I can take up the questions. I request Kunal to read out the questions, and then I will answer them in detail. If there is any question which ever comes to your mind, you can raise those questions for a later on discussion.
Hello. Yeah. So thank you for the session. We have a few questions. Like first, how we compare basically energy efficiency and renewable energy projects while taking a decision?
Great question. See, what happens is a renewable energy project, right, is comparatively easy to implement, right? Because you are going to measure the success of renewable energy project based on the energy generation, right? Because sun is there, right? We can't foresee a situation wherein sun is not there, right? So you're going to get that much of solar insolation on your solar photovoltaic system, right? So you will generate that much of energy, right? So decision, it's purely a financial, right? There is no technical challenge. There is nothing into it, right? Of course, there is a best practice which you have to implement so that you don't land up into a situation wherein you are generating less level of energy, right? So that's what a renewable energy project is, right? But renewable energy project doesn't reduce your energy consumption, right? Because there are many renewable energy projects wherein the fuel source is changed, right? For a boiler, the diesel-fired boiler, or a furnace oil-fired boiler, or a PNG-fired boiler is converted into agricultural waste-based briquette, right? So definitely agricultural waste-based briquettes are carbon neutral, right? And the cost is also quite low, right? So renewable energy projects are usually big projects, much bigger project with much higher, very, very high level of investment required. Whereas energy efficiency projects can be very small, right? And it can be implemented very quickly, right? And the before consumption and after consumption, right, is the way it is demonstrated, right? Whereas a renewable energy project can even be done in a isolation kind of a situation, right? So there is a fundamental. I mean, the purpose of a renewable energy project and an energy efficiency project looks that both of them are for energy cost reduction, but the context is completely different. Like one customer we are working for, they are actually looking for a net zero situation. That means that they should be whatever energy they are consuming should be completely generated from a renewable source. That's one way to do it, right? Or whatever energy they are consuming, generating, that much energy only they should consume, right? However, with this method, they use their full rooftop, and they reached out to only 50 to 60% of their energy requirement, right? So what do you do for the next, right? The way out is reducing the energy consumption into different systems. And energy efficient technologies are really plenty, right? And as the years are passing by, so many new technologies are coming up, right? And they can really change the picture. So that's the fundamental difference between both of them. Yeah.
So, thank you. We'll go to the next question. Next, we have what is laundry revamping project? Can you explain a bit?
Sure. See, what happens is basically in any steam utilizing project, you have a boiler, right? That boiler is usually far away from the application place, right? And then you have the condensate, right? But there are certain kind of boilers wherein condensate recovery is not possible. So this was such a case, right? So whatever was the condensate, that was actually getting into complete waste, right? And then the laundry behavior is in shift, right? Sometimes it is one shift, sometimes it is two shift, right? And you require hot water also in a hotel. So that hot water requirement is 24 hours, right? So you can't stop the boiler. So in this kind of a situation, what happens is your distribution losses, right? What we normally call only in case of electrical system, but it is equally applicable to thermal systems as well, right? So they were plenty. They were, I mean, quite a lot, right? So what we did was we revamped the laundry means we wherever there was still a steam required, right? So we installed uh, that size specific non-IBR boiler, right, wherein we generated the steam at the location itself, nearby the machine itself, to reduce the distribution losses, right? We generated steam in batches, right, because the requirement of steam consumption was in batches, right? So that steam cost, right, if you move from petroleum fuel to electrical, you will calculate that your actual steam cost is much higher, because if you see how much of kilocalorie you can generate by consuming one unit of electricity, and then what is the cost of that electricity, so you will always find that your rupees per kilocalorie, right, is actually very high in electrical, right? But the point is, it is not the costing only at the consumption point. It is the overall always, right? So that's what's the laundry retrofit project, wherein we generated steam then and there, wherein we converted the machines, we retrofitted the machines, right, into another source of energy kind of a situation, right? And this laundry retrofits also we have done plenty, but again, different laundries are using different equipments, different brands. So the intricacies involved in finally doing the revamping project is also quite different for every different case. If there is a specific case that is there, if that is shared with us, we can guide you how to achieve savings there. Yeah. Next question, Kunal.
Yeah. So next question is, what is CTI approved?
Oh, great. Yeah. See, for everything there is standard, right? Like for example, motors, we have Bureau of Indian Standards, right? We call it BIS standard. BIS standard is there for every thing, right? So same way for cooling towers, right? This is CTI, Cooling Tower Institute, right? This is the institute which is respected worldwide, right? For cooling tower. It's a specific institute, right? Which is only for cooling tower, right? So they have made certain standards, right? That if this is the given condition of climate, I mean, this is the DBT, this is the WBT, right? Then the cooling tower, when you are operating it, then cooling tower should give you this kind of performance, right? So they have given that kind of standard, right? If we manufacture the cooling tower based on that standard, that cooling tower will normally cost us at least 20 to 25% more, right? And at the time of project implementation, that is not done, right? But here our objective is to get the maximum cooling, right, in the cooling tower, because your 1 degree centigrade reduction in the cooling tower temperature, which is coming out from the cooling tower, can do wonders in terms of savings in your compressor, air compressors or chiller or anything, any location wherein cooling is required. That's why it is always better to use that, right? Yes. Next question.
Thank you, sir. Sir, what is ATCS online condenser cleaning system?
Okay. See, what happens is the normal situation is that cooling tower water comes to the condenser, right? In a chiller, we all know, right? Now what happens is in the condenser, it takes the heat rejected, and again the water goes to the cooling tower. So that's how your circuit is, right? But whenever you heat water, I'm not saying boiling, right? Even if you heat water, right, in a utensil, right, and you do it on a home kitchen, you'll find that there is a white layer which is getting continuously established, right, inside your water container, your utensil, right? So that what is happening, right? There is a TDS in the water, right? That is called as total dissolved solids. So as you heat it, it starts getting what I should say away from the dissolved situation, and it gets on the surface of the utensil. So same phenomena is happening in the condenser also. So when this TDS, right, which gets which is actually dissolved in the solid, so it comes out of water, right, and it gets deposited on the condenser tube. It reduces the heat transfer coefficient, right? So when it reduces the heat transfer coefficient, right, with the same flow rate of your cooling tower water and with the same temperature of your cooling tower outlet water, which is your condenser inlet temperature, right, you are going to get lesser cooling, right? And this is happening as a continuous sense, right? Normal practice is that some locations will do condenser cleaning once in 6 months, some will do once in 3 months, some will do once in 1 month. But the fact is, if you do it on a continuous basis, right, so this technology allows us, there are rubber balls which are continuously in rotation, right, on the inside the condenser tube, right? Condenser tube would be something like a half an inch or an inch kind of sizes. So in that size, there are very small sponge balls are there, right? So with the water force, they keep continuously moving, right, in that condenser. So that's how it cleans the condenser tube, right? And that's how your condenser tubes are continuously cleaned, right? After a certain time, you have to replace those balls, right, to get the good outcome from the performance of ATCS. So ATCS is actually automatic condenser tube cleaning system, right? So if your water is having higher TDS and if your chillers are running continuously, right, and if your chillers are of a particular size, then definitely ATCS is very strongly recommended, right? But don't jump because any technology is good, right? For your chiller, there might be something else, right? Maybe cooling tower performance improvement may be a good thing for it, right? So like this, the project must be evolved, right? Not that one medicine good for all. Yes. Next question, please.
Yeah. So because of time constraint, we will be taking one question. Remaining, we will be answering personally to everyone which are there. So the last question is, out of IPMVP 4 methods of monitoring and verification, which is most preferred and which should be used?
See, again, without defining the project, we are trying to arrive at which medicine is good, right? Without arriving it at, right? So it completely depends on the type of project. It completely depends on the level of project implementation, right? Again, I'll repeat, if you're doing one energy efficient motor, right, as a trial case, right, that to find out how much of the savings are there, right, then obviously that motor before KW and after KW is sufficient, right, to get the savings. And both of these things are exactly and very clearly measurable, right? Okay. However, if there is a cyclic load, right, then you cannot go by 1 kilowatt measurement, right? You have to go by kWh measurement. And in the kWh measurement, you have to do it through cyclic. So for that is the case, right? Whereas there is some facility which is saying that no, we want 20% reduction. So then you have to implement so many projects, right? At least 6 to 8 projects across the facility, right? Then you are not going to measure the savings at different individual cases. And the baseline is also very, very stable. But unfortunately, because of COVID, there is no facility wherein today we can get the stabilized baseline. So in today's scenario, either option A or option B, right, would work out the best. Yeah. Thank you. So we can end this session here. If you have any questions, please do write to us, right? And please do join the next session, right? We'll discuss one particular aspect in every session as we have promised, and we'll take it up there. Thank you. Over to you, Bhavna.
Yeah. Thank you for joining, and we hope that you'll be again with us next Tuesday, same time at 4 p.m. And we request like if your peers are also interested into this, we will be sending them the link, or we can send them also the same link for registration which you have received. So hope to see you all again next Tuesday. Thank you. Thank you.
Thank you, everyone. Bye-bye.
Bye.